yesterday we talked about mixture word problems, okay? This is really the same thing as yesterday's. It's just that there's a slightly different thing about it, and some of you already noticed it. It's really quite simple. But as long as you do the box, these are really quite simple. And as you understand that mixture formula that goes on the top of the box, then you just have, it's very clear where to put what. So we've got, what are we talking about? Solution, this power booster. So we have amount of solution times the percent of power booster, PB, equals the amount of PB. Okay? So that's our box. We're going to have 3 rows and 3 columns. And we have, okay, so I'll give you a second to write that down, that box. And then it's a matter of just reading the problem and putting everything into the box in the right way. The first thing it says is I have 800 milliliters of a solution that is 5% power booster. So I put 5% here to just remind me that's the one I'm talking about. And this is, since this is percent, I would write it as 0.05. Now it says I have 800 milliliters of it, so I'm going to put, that's my amount. I have 800. And then it says how much pure power booster, so I'm going to write pure here. Okay? What does pure mean in terms of percent? 100%. Pure is 100%, whatever that is. If you have pure orange juice, it's pure, 100% orange juice, right? If you have pure salt, it's pure 100% salt. You have pure power boosters, 100% power booster. So I'm going to put 100, I'm going to write this, that 100%, how would I write that as a decimal? 1, right? So there, boom. Because 100, you bring the decimal over 2 places, it's just 1. And then it says, okay, how much pure power booster? That's the amount, right? How much is the amount? The amount of power booster. So that's X. That's what they're asking me to solve for. All right, we're almost there. It says, okay, and how much of that power booster should Sina add to get a solution that's 20%? This is my mixture, right? And that's going to be 20%, 0.2. All right? That's what I'm being asked to do. So the question is, so now that's what they give me, and I look at my box and I see that I'm missing something. What am I missing, John? Yeah, the amount of the mix. I need to have that. Then, just like rate times time equals distance, all I have to do is multiply this times this to get this. This times this to get this, and this times this to get this. But first I have to know what this is. This is a mixture of these two things. What's the amount of these two things? I have 800 of this, and I have X of this. So what would this have to be? 800 plus X, right? Not times X, but 800 plus X. You're just adding each mixture together. That's all it is. So now you just multiply it out. I think I did this one. Did I do this one? I didn't. Does anybody have a calculator?
Yes.
Thank you so much. Oh, you're fast. Okay, so 800 times 0.05. 0.05 is, where's your equals? Ah, there it is. 40. So there's 40.
40. Oh, you were
So you guys listening?
40.
Really? Are you getting it? Is it making sense to you this time? All right. Well, I'm going to ask you a question in a second, so try to see if you can do it. Okay. What's 1 times X?
X.
Right. What's 0.2 times 800?
160. Sorry.
Is it? Okay.
Yeah.
160. Thank you. Plus 0.2x. Okay. Now, what do I do as my formula? Now, or my equation?
Do 40
So,
equals
40 40 plus this equals this. Remember, the amount of power booster in the first solution plus the amount of power booster in the second solution has to equal the amount of power booster in the mixture of the two, right? Makes sense. This plus this has to equal this. So I just write that. 40 plus x is equal to 160 plus 0.2x. Now I'm going to subtract 40. I'm going to subtract 0.2x. Subtract 0.2x. I'm doing it all in one long thing. So those cross out. This becomes, what is that, 0.8x is equal to 120. Those cross out. So I divide by 0.8. Who has, do you have that? Should I do that? 120 divided by 0.8 is equal to 150. So x is equal to 150. So what does that mean? Have you written all this down, John?
No, I have.
But I just wrote 150. You didn't write that.
Well, is the power booster?
You didn't write this whole thing. Write that whole thing. That's part of the solution, right?
Is the power booster a liquid or a...
Power booster is it's an ingredient in the liquid, all right? Or in this case, yes, it's a power booster liquid. I mean, it's, I don't know. I don't even know what power booster is. I just made it up, right?
Okay, so would it be a liquid or a solid?
Probably a liquid because we're talking solution.
Yeah, or pure power booster.
Well, no, if it's not a liquid, then we
have
to
to probably be like powder.
Add to water.
Okay, so maybe it's a powder, maybe it's a solid. I don't know. I don't care what it is. But I just know it's pure. Okay? Okay. So now what's my answer? I go back and I look. It says how much pure power booster should she add to get a solution that's 20% power booster? We're talking milliliters. That's what we've been dealing with. So how much? 150 milliliters. That's the amount of pure. I just have to look at my box. So guys, I'm serious.
I didn't even do anything.
I need you guys to pay attention. Teddy, do not distract her. Do not say a word. I need her to pay attention right now. All right, I just solved for x. It's 150. I look at where x is in my box. That's the amount of solution. That's what they're asking for. How much of the pure? Right there. So it's 150 milliliters. So 150 milliliters of pure. And that's my answer. Okay? That makes sense? So this is really not different than the ones you did last night. So if you understand this, you will understand the ones last night. The key is the box and filling in each part of the box. It just takes a little bit of logic, but it's not hard.
Time.
And time, definitely. You know, it's a little more complicated than I think than the rate times time, just because you've got more stuff in there, right? You got an extra row, stuff like that. Can I erase? Yeah. All right, so we got one more to do, which is actually rather different than the ones we've been doing. Okay, two. So Teddy and Beckett and who else? Lila. And that's it. So please, I don't care. I want you to write the problem now as I write it. So I don't want to waste a lot of time right now. So how much water must be evaporated from 40 liters of a 15% orange pulp solution. Whoops, pulp solution to get a 40% orange pulp solution. So the first thing is just set it up. The first thing is 15%. I'm going to write that. And it says how much water. But this now we're not doing a mixture, are we? You see the difference? What does evaporate mean? What are you doing? You're taking something away, right? Like whenever you boil water and the steam rises, it's evaporating, right? Eventually that water in that pan will disappear because a lot of the water is leaving, right? So now are we adding or are we subtracting? Subtracting, right? So that's the big difference. So now we've got water here, and then we have, I don't know, I can't call that a mixture because we're not mixing them together. We're actually, it's actually a final, more pure, right? You see what I mean? It's a more pure solution, right?
Separating? Like, sort of. More pure.
Final, I'll just say less mixed. Less mixed, I don't know. Right? So we've got amount of solution. We've got percent of orange pulp, OP. And then we have amount. That's times and that equals amount of OP, orange pulp. So what would I put where? How much water? First of all, what's the percent of orange pulp in water?
15.
In orange pulp. In water. Right? In pure water.
Pure water, 0.
It's 0, right? So that's immediately going to be 0% or 0.0. Or 0.0, whatever. It's just 0, right? Because water doesn't have orange pulp in it. Pure water, right? 15%, I know that's going to be 0.15. Now, did they give me an amount? Oh, look. Of the 15%, it says 40 liters. So, obviously, that goes in the amount of that 15% solution. That's 40. Okay? Now, how much water? Do we know? So, what do I put here?
X.
X. If you don't know it, that's what they're asking us to solve for. How much water? Now we've got those two. Now it says how much does it have to be evaporated in order to get a solution that is 40%. So that's the percent column. So I just put 0.4. And the only problem is this. Doggone it. This is blank
40
again.
minus X?
Say it again.
40 minus X?
Yeah, why minus X?
Because you're taking it away.
Because you're taking it away. It's evaporating, right? Does that make sense, Sina? I mean, Sina. Tiana, does that make sense to you? It's evaporating, so it's 40 minus the X. The water is what's evaporating, right? So it's the solution, 15% solution, minus the water. That's what would go here, right? Does that make sense?
Yeah.
Right? 40 minus the water. Okay. So now we just do our multiplication again. Has anybody done it, or should I do it?
First one's 6.
This is 6?
0. And the third one's 16 minus 0.4x.
Great. Thank you so much. That makes it so easy. So now what do I do with this?
We do 6
This minus 0 is equal to this, right? This, the 15% solution minus the water is equal to this, the remainder, right? The less mixed mixture solution. So we've got 6 minus 0 is equal to 16 minus 0.4x. So we don't need the 0. So I'll just rewrite it as 6 is equal to 16 minus 0.4x. Now, I should probably just say one thing real quickly. Some people choose to multiply some people don't like to work with the decimals like this. I personally like the decimals. I prefer to just keep it the way it is. But some people don't. Some people say, oh, well, that's 0.4. If I multiplied everything by 10, I would be dealing with something without decimals. And if that's easier for you, that's fine. If I did that, I'll just do it that way, since it's different than the way I've been doing all the others. I'm going to multiply everything by 10. And that gives me 60 is equal to 160 minus 4x. Now suddenly I have no decimals at all. It's just a regular, you know, problem. So I'm going to subtract 160 from both sides. So what would I get here? Negative 100 is equal to negative 4x. I would divide both sides by negative 4, divide both sides by negative 4.
X equals 25.
X is equal to 25. So, we solved for x. So, how much water must be evaporated? So, that's my x. So I look in my box, oh, that's the amount of water. That's what I solved for. 25 what? What? Liters, right. So 25 liters of what? Water must be evaporated, right. So that's my answer. All right, where are we? Whew. Okay, so I'm going to give the homework, hand out the homework now. You guys can get started. Oh, let me just turn this off.